Welcome to this tutorial series on baked performance editing using HoloEdit and HoloSuite's included Maya plugin. We'll walk through generating a skeleton on a pre-stabilized volumetric clip and exporting it from HoloEdit to use in Maya. Using the skeleton generated in HoloEdit, we'll add skin weighting to make changes to the animation of the volumetric performance, allowing us to adjust the actions taken by the actor. Set those changes and export the mesh as OBJs. We'll take a clip of a kickboxer shadowboxing around the capture stage and tweak their performance to integrate a punching bag into the scene. After adjusting the animation, we can export our changes as OBJ files to bring back into HoloEdit for compression and create an OMS with our edited performance. This tutorial requires basic familiarity with HoloEdit and experience with rigging and basic animation principles in Maya. So you can follow along, we've provided the clip data in a HoloEdit workspace, as well as a copy of the completed workspace and the final Maya scene. We'll be working on a clip that has already been stabilized. We'll start by installing the HoloEdit Maya tools and setting up our shelf in Maya. Go to your HoloSuite download folder and access the Tools folder. Inside of that, select the Maya folder. Included is a README file containing the steps required to install the HoloEdit tools for Maya. In the folder containing our Maya tools, open the HoloSuite module path.mod file. This file is used to set the location for our scripts in Maya. We'll set the paths to the location of our scripts inside of our HoloSuite directory. Next, we'll open Maya to get the location of the Maya modules path. Open the script editor and enter git env Maya module path in the mel command line. Execute the command to get a list of paths that Maya searches for .mod files. We'll copy the first path. Open an Explorer window and navigate to the path that we copied. Then copy the edited mod file into that location. With the mod file installed, we can restart Maya. The HoloSuite shelf panel will be visible. Next, we'll prepare our clip for export from HoloEdit. We'll start by creating a new workspace from a directory that has our clip data. We'll press the Make Clip button to import our clip into HoloEdit. This clip has already been stabilized in HoloEdit ahead of time, so we'll need to enable Detect Stabilized Sequences so our clip loads in with the segment data ready. Baking new animation into a long clip can be a time-consuming process, as the animation process itself requires time to block out and add finesse to achieve good results. Having the base animations already present with a volumetric capture helps to speed up the process, especially when we're only making small changes to the actions being taken by the actor. Still, we'll be working on a small clip while we cover the basics. Once the clip is imported and added to the composition, we'll add a Generate Skeleton stage and create an interval for the whole clip. Let's take a look at the Generate Skeleton parameters. For this clip, we'll leave everything at default. It's possible we could get more accurate results using a higher number of views, but it's likely that most of the capture will process correctly with the default value of 10. Since a lot of the processing time involved in Generate Skeleton is tied up by making and uploading the MVEs used to generate the skeleton, being able to process the whole skeleton at a lower number of views will save a lot of processing time. Once the clip returns, we can review it and make adjustments to individual intervals if we have any unsatisfactory results. Once you've reviewed the settings, right-click and execute the Generate Skeleton interval. This will take a few minutes to generate the skeleton for the clip. Let's jump ahead to when it's finished. Scrolling through, it doesn't look like any of the bones have been generated out of place. Playing through the clip, there's a bit of jitter in the skeleton results. We can correct that using the Stabilized Skeleton stage. Let's add that stage to the track. Click Add Stage in the Composition window and select Stabilized Skeleton. We only have one option here, window size. The Stabilized Skeleton stage works by interpolating the motion of the skeleton over a series of frames, driven by the window size parameter. For a clip like this, with no noticeable defects in the skeleton, using the default size of 4 should work well. If we were to use too large of a size, we would get a nice, smooth performance, but it would also dampen and reduce the movement of the boxer's arms while striking. The default of 4 should help with the jitter without affecting the power in the boxer's strikes. We'll ensure that we have an interval for the whole clip and hit execute. This process is quite quick. With the stabilization of the skeleton complete, we'll take a moment to review for any remaining issues. This looks good. There are a few points in the arms where it feels like they could snap a little more sharply, but we'll be making adjustments to a lot of the strikes in Maya, so that bit of over-easing is okay. With our clip prepared, it's time to export it for further editing in Maya. We'll select Export Composition from the File menu, then select the export location. We'll create a folder in our export folder called Baked Editing, and select that folder as the export location. Next, we need to add an export step. Due to performance limitations in Maya, we suggest working in frame ranges of 200 or less at a time. Larger frame ranges may result in poor performance inside of Maya. Next, select the output sequence type. We'll select Workflows and select Maya as the workflow type. We'll set the file name for our export to Baked Editing. It's important that your name doesn't include any spaces for Maya to be able to detect the textures. We'll save the settings and begin our export. The Maya workflow export will produce a single FBX containing the mesh, skeleton, and skin binding, and a sequence of PNG textures. In the next video, we'll import our clip into Maya and begin editing the performance. Thanks for watching!